Okay, chemistry, we are going to do the next section. So I'm going to share my screen here so that you can see the slides that we're going to do for the next section called percent yield. So get out your notes that I've given you or have those somewhere where you can see them, and let's see what this is. So first of all, we're going to define theoretical yield. Using stoichiometry, the amount of product that should be produced, that's what we've been finding out so far. We say, okay, we have this much of our stuff that we're going to use in our chemical reaction, and how much should be produced of our product. We can calculate that. That's what we've been doing. This is called the theoretical yield. It's what we should get if everything is perfect. Theoretically speaking, that's what we should get. So theoretical yield is the maximum amount of product produced from given amounts of reactants based on stoichiometric calculations. Okay, but sometimes that doesn't happen. Sometimes we don't get what we should get theoretically. So the actual yield is the amount of product actually produced from an experiment in the lab. If we actually take these chemicals and do this reaction, how much do we end up with? So the actual yield is the amount of product actually produced from an experiment in the lab. This value will be given in the problem. Okay, they're going to tell you that value somewhere in the problem. Percent yield, which is what this section is called, is the actual amount of product produced compared to the theoretical amount. Okay, what did we actually get in the lab, and should we have gotten? And we're going to compare them, and we're going to change it and state it as a percentage. Okay, most often a reaction will not yield 100% of the ideal or theoretical yield. So situations that could affect the amount of product produced are experimenter error. So the people who are actually doing the experiment maybe made an error some way. The reaction does not go to completion. So we don't wait until all the way to the end and it doesn't really work. Loss of product, maybe something spilled, maybe something evaporated while you were doing it. And the purity of the reactants. So maybe the chemicals that we're starting with aren't completely pure, and so we're not going to get the theoretical yield. So those are some ways that can cause this to happen. So here's our formula for finding percent yield. It's a little bit, well, no, I won't say that. Never mind. So percent yield is the actual yield. That's what the actual yield you get in the experiment divided by the theoretical yield, what you should have gotten, times 100. Remember that the actual yield is going to be given to you somewhere in the problem. The theoretical yield you might have to figure out. That is the kind of thing we have been figuring out in these other stoichiometry problems. Okay, the actual yield is given in the problem. The theoretical yield must be calculated using stoichiometry. So let's try one. Ready? The double replacement reaction between potassium iodide and lead to nitrate is run in the lab. Okay, so the first step is to write a balanced equation. We are going to have to write a balanced equation. We're going to have to write potassium iodide and lead to nitrate. So we're going to have to write that equation, and then it says that it's a double replacement. So that means then, well, here, let's start it. First, we need a balanced equation. All right, so we got potassium iodide and lead nitrate. Okay, so we actually made the equation, And then actually, let's go back and do that on the whiteboard. To make the equation, so you know what that means. If you have an equation if you have a problem like this, we need potassium and iodine. Okay, so you're going to look at potassium. It has a +1, I think. Let me get out my periodic table. Oh, I took my periodic table downstairs. Okay, potassium and iodine. So that becomes potassium iodide. And then we have lead, 2. And we have nitrate. Oh, that was bad. Let me make my N a little better. And we have nitrate. I don't know why I put a parenthesis around it. And the charge for that is -1. So when we do this, that becomes lead nitrate, like that. So then the equation says that we have potassium iodide plus lead nitrate. And it's double replacement. So that means that the potassium now is going to go with the nitrate, and the iodine, whoops, other way around, and the lead is going to go with the iodine. So now we have potassium and nitrate, and this is +1, -1. So that becomes KNO3. And we have lead and iodine, and lead is +2 and iodine is -1. So that becomes, whoops, lead, let me write that a little better. That becomes lead iodide, like that, with a 2, because the 2 went over there. Okay, so there is our equation, and we need to balance it. So we got to look at it. Is it balanced? Let's see, 1 potassium, 1 potassium. But look, we have 2 nitrates here, and we only have 1 over here, so we better put a 2 there. But if we put a 2 there, that gives us 2 potassium, so we have to put a 2 here, which gives us 2 iodines, but we have 2 iodines over here, and we have 1 lead, and we have 1 lead. So everything is balanced. So there's our balanced equation right there. Okay, so that's your first step. Now let's go back to our slides. So there's our balanced equation. That's what that is. Yeah, that's what I had. And step 2 is we're trying to find the percent yield. They gave us the actual yield. We have to find the theoretical yield. Remember, the actual yield is given in the problem. So now we have to calculate the theoretical yield using stoichiometry. We're going to start with what we're given, which is 65 grams of lead to nitrate. Okay, and then we change the grams of lead to nitrate to moles, and then we change the moles of that to moles of lead iodine, because that's what we're looking for. We're looking for the percent yield of lead iodine. And then we change the moles of lead iodide to grams, and we get 461. This is a stoichiometry problem like we have been doing. Oh no, 461 comes from the periodic table. We get 90.5 grams of lead iodide. That's the theoretical value. That's how much we should have gotten. But how much did we get in the experiment? You got to find that from the problem. Look up in the problem. How much did we get? We got 74.8. So to find, there's the actual yield. So now we're going to use the equation to find percent yield. we're going to take actual divided by theoretical. So 74.80 divided by 90.5 times 100. It's going to give us a percentage of 82.7. Listen to me very, very carefully. Percentages have no units. The percent is the unit. Look at the problem look at the step right above the percentage, 74.80 grams of lead iodide over 90.5 grams of lead iodide. The units cancel each other. They go away. There are no units except percent. So our answer is 82.7%. All right, let's try. Now this says you try one. So you go ahead. Maybe this is a good time for you to pause the video and try it yourself. Okay, the equation is already there for you, and it's all balanced. Everything is balanced there. You don't have to worry about that. So it says this reaction was run with 23.5 grams of LiOH and an excess of potassium chloride. That just means that's the other reactant. Don't worry about that excess thing. Okay, 18.85 grams of lithium chloride was produced. What is the percent yield for this run of the reaction? So we need to start with 20. We need to find the theoretical yield of lithium chloride. So what did we start with? We start with 23.5 grams of lithium OH. We're going to change that to moles. We're going to change moles of that to moles of lithium chloride. We're going to change moles of lithium chloride to grams of lithium chloride. And we get 41.6 grams of lithium chloride. That is the theoretical value. What was the actual value? Only 18.85 grams is the actual value. And that is up in the problem. So we're going to find percent yield, and we're going to take actual divided by theoretical times 100, and we're going to get 45.3%. No units. 45.3% of the theoretical value did we get in our equation. Okay. What about this one? This is going a different way. Okay, here's our equation. Here's our balanced equation. When this reaction was run, it resulted in a 76.4% yield. It was reacted with 19.5 grams of calcium oxide and an excess of sodium chloride. Okay, that just says we're not going to care about the sodium chloride really. We're dealing with calcium oxide, which is CaO. What was the actual yield for calcium chloride in grams? So now it's asking us for something different. It's not asking us for the percent yield. It gave us the percent yield, and we can find the theoretical yield, so that means we can find the actual yield. In the other two problems, it gave us actual, we found theoretical, and we found the percent. But now we just have the percent, and so we're going to go backwards. So I'm going to share the whiteboard and do this one on the whiteboard for you so that we can see what we're doing. All right, we are given 19.5 grams of calcium oxide. Okay, you always start with what you're given. And when you're given grams, you have to change it to moles. That's always the first step. And how do we put these numbers in here? When you have moles to grams, one goes with the moles. And this number right here comes from the periodic table. You're going to look up calcium and oxygen, and you're going to get 56.08. Then we're going to Okay, so see how this went down here? So now moles of calcium oxide go down here, and we have to change it to moles of something else. What are we looking for? We're looking for the product of calcium chloride, which is CaCl2. So we're going to change it to moles of calcium chloride. How do we decide what numbers go here? From our balanced equation. We're going to, let me write it here for you. You have it in your notes. Okay, what number is in front of CaCl? 1. What number is in front of CaO? 1. So those are just ones. And then we've got moles of calcium chloride there. So moles of calcium chloride go on the bottom, and we're going to change it to grams of calcium chloride. That's what we're looking for. When you have grams to moles, a 1 goes with the mole, and this number comes from the periodic table. 1 calcium, 2 chlorides, and you should get 110.98 grams. So look at this. This went here, so they cancel. This went here, so they cancel. This went here, so they cancel, and we're left with grams of calcium chloride. So do all these calculations on your calculator, and you should get 38.6 grams of calcium chloride. What is this? This is the theoretical yield. That's what we should get if we do this experiment completely perfect. That's what we would get. So now we're looking for, remember our formula is percent yield equals actual yield over theoretical yield times 100. But in this problem, in the problem, it gave us percent yield. We just found theoretical yield, so now we can solve for actual yield. How could we solve this equation for actual yield? Well, we want actual yield to be by itself on this side, so I'm going to divide by 100, both sides by 100, because that got rid of that, and I'm going to multiply by the theoretical yield so that it goes to the other side. So rearranging this formula right here to solve for actual yield, we get percent yield times theoretical yield divided by 100. So percent yield was given in the problem. It was 76.4. And theoretical yield was right here, 38.6. And we're going to divide by 100, and that's going to give us 29.5 grams of calcium chloride. So when this experiment was done, this is how much calcium chloride they ended up with, even though theoretically they should have ended up with 38.6. So let's go back and look at the slides and see if we did it right. All right, let's see. There's percent yield. So here it was the first thing which we did to find the theoretical yield of calcium chloride, which was 38.6 grams. Remember how everything cancels. When you are doing these problems, put the units on your paper. I see you attaching pictures and you're not doing that. If you put the units, then you're not gonna forget any. So then here's our percent yield equation. We're gonna rearrange it to solve for actual yield, substitute in what we know, and we get 29.5 grams of calcium chloride. All right, there are two more problems here for the notes. Partner challenge. In a single replacement reaction between aluminum, copper, and copper 2 sulfate, 2.15 grams of aluminum is reacted in excess copper 2 sulfate. Okay, that means we're not dealing with the copper 2 sulfate, and a 59.5% yield was obtained. What mass in grams of copper was produced? This is just like the problem we did. We're looking for the actual yield. They gave us the percent yield, and we can find the theoretical yield, and so then we can solve it. Okay, so the first thing you have to do is write the equation. Aluminum and copper 2 sulfate, and it's a single replacement. That means, okay, there's our percent yield. All right, here it is. Aluminum and copper 2 sulfate is CuSO4. Single replacement means now aluminum is going to go with the sulfate and copper is going to be by itself. So this is the equation, and it's all balanced here for you. You need to know how to do that. We've done that in past chapters. Those are things that you should be able to do. Get out your notes and find out how to do it if you don't remember off the top of your head. Now, what are we given? We're given 2.15 grams of aluminum. So we're going to change the 2.15 grams of aluminum to moles of aluminum, change that to moles of copper, change that to grams of copper, and that's going to be our theoretical yield. Okay, 2.15 grams of aluminum, change to moles of aluminum, change to moles of copper, change to grams of copper, and our theoretical yield of copper in the end is 7.60 grams. Our actual yield is what we don't know, and we're going to rearrange our formula like we did the last time, so that actual yield equals this. Substitute in what we know. They gave us a 59.5% yield, percent yield, and then 7.6 is our theoretical, divide by 100, and our actual yield is 4.52. So whoever did this experiment ended up with 4.52 grams of copper, when theoretically, if everything would have been perfect, you should have gotten 7.6 grams. Okay. One more on your own. Again, it's an equation that they haven't given you that you're going to have to do. You're going to have to write iron 3 phosphate reacts with sodium sulfate to produce iron 3 sulfate and sodium phosphate. So it's one of those double replacements. Okay, I'm just going to show it to you. You can stop this right now and try it and see if you know how to do it. Get out your polyatomic ion chart and all of that. And then there's our actual yield, and we're looking for percent yield here. This time we're going back to our original. So here is our balanced equation. Here's iron 3 phosphate, FePO4, and sodium sulfate, Na2SO4. And then they switch, and the iron goes with the sulfate, so it becomes Fe2SO4(3), and the sodium goes with the phosphate, so Na3PO4, and then balance the equation by putting these coefficients in front. So there's the balanced equation. We are given the actual, we have to find theoretical, starting with what we're given, which is 27.0 grams of iron 3 phosphate. So we're taking those 27.0 grams, changing them to moles, changing it to moles of iron 3 sulfate, and changing it to grams of iron 3 sulfate. Make sure you know where all those numbers come from. If you do not know where they come from, you need to send me a message so that I can explain it to you. If it is moles to grams, the moles is 1 and the grams comes from the periodic table. If it's moles to moles, the numbers are from the coefficients of the balanced equation. Here's grams to moles, so 1 for the moles, and this 399.91 comes from the periodic table. Do these calculations and you get 35.8 grams is the theoretical value. They gave us the actual value. Look, it's very different. 18.75, 35.8. That means the percent yield is not going to be close to 100. If they are exactly the same, then it's going to be 100. The farther apart they are, the smaller the percent yield. So percent yield is actual over theoretical times 100. And that becomes 52.4%. And that is the answer to the last one for these notes. So I'm going to go over a little bit of the start of the homework. For these notes, you have one homework problem. Okay, one homework problem. It's the check for understanding. They gave you the equation, NaCl, and they put these in H2SO4 and Na2SO4 plus HCl. Okay, it says balance to the equation above. It should say balance the equation above. So let's balance this together. Let's see, we've got 1 sodium and 2 sodiums. So we better put a 2 here. Now we have 2 sodiums on both sides. That gave us 2, this 2 here gave us 2 chlorines also. So we better put a 2 here so that we have 2 chlorines. Now we have 2 hydrogens and 2 hydrogens. And we have 1 SO4 and 1 SO4. So putting this coefficient and this coefficient and this coefficient balances our equation. So now our equation is balanced. So it says, if 24.5 grams of sulfuric acid is reacted with an excess of NaCl, that means we are not going to worry about the NaCl. We are worrying about the sulfuric acid, which is this. So that's what we're given, 24.5 grams of sulfuric acid. And 15.5 grams of hydrochloric acid, HCl, is produced. So this is what we're dealing with on the product side. So that means we're going to change these grams, 24.5 grams of H2SO4 to grams of HCl. So we're going to put these units on the bottom. And we're changing it to moles. Whoops, that's an H. And then we're taking those units and putting them on the bottom and changing it to moles of HCl because that's what we're dealing with on this side. And then we're going to put those on the bottom and change it to grams of HCl. So that's the first thing you need to do. Put all of these numbers in, find what they should be, and find an answer for grams of HCl. And that answer is your theoretical yield. And then you can find your percent yield by taking your actual yield, which they gave you in the problem. What is the actual yield? How much hydrochloric acid really was produced? 15.5 grams. You see that? And then you're going to put your theoretical down here, and you're going to multiply by 100, and that's going to give you your answer. Okay, that's all you have to do. You got to finish that homework problem for these notes.